I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. What if your doctor could measure things like sodium levels in your blood without needles? Well, researchers in China are working to make it happen. A team at Tianjin University has designed a non-invasive system that merges terahertz spectroscopy with optoacoustic detection to measure and monitor blood sodium levels, the assessment of which is key to diagnosing conditions like kidney disease and certain neurological disorders. The new system involves blood samples being illuminated via terahertz waves. The samples then absorb those waves while also vibrating sodium ions in the blood's water molecules. This creates ultrasound waves detected using an ultrasonic transducer. The team says this approach essentially turns the absorbed terahertz energy into sound waves that can be measured. In mouse models, the new system was able to measure increases in blood sodium level within blood vessels under the skin. Tested on human blood samples, it was able to rapidly discern between high and low sodium levels. The work is ongoing, but the team says their results so far show promise for real-time clinical diagnostics. A universal quantum computer is now in the pipeline at QuiX Quantum, thanks to recently awarded Series A funding. The Netherlands-based quantum computing developer will get 15 million euros following an award of European Innovator Council Accelerator Program funding meant to aid companies in their creation of transformative technologies. QuiX Quantum will use the funding to accelerate their development of a single photon-based universal quantum computer for large-scale fault-tolerant quantum computing that can ultimately support any quantum operation. In other business news, semiconductor technology developer STMicroelectronics and metasurface optics developer Metalenz are partnering to boost the manufacturing of metasurface optics products. Officials say the move will essentially bolster advanced metasurface optics based on STMicroelectronics' manufacturing platform that combines the production, testing, and qualification of 300mm semiconductors and optics. Researchers in Europe are now investigating one of the most fascinating predictions of quantum electrodynamics, which they say could ultimately make all of it tangible. A team of physicists from the University of Oxford in the UK and the Higher Technical Institute at Portugal's University of Lisbon have designed real-time 3D simulations showing that intense laser beams could alter the quantum vacuum, a state of quantum physics that's predicted to be filled with virtual electron and positron pairs. The simulations also recreated vacuum four-wave mixing, a theoretical quantum effect in which the electromagnetic field of 3 focused laser pulses can separate the virtual electron-positron pairs of a vacuum and make photons generate a fourth laser beam. The simulations were done via advanced computational modeling to mimic interactions between laser beams and plasma, which is the fourth state of matter. Ultimately, the work provides more detailed data for quantum experiments. The team says their work challenges the long-standing idea of a quantum vacuum as an empty space, instead showing it could be an area filled with virtual particles. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.